Alrighty, boys and girls, today we want to talk about if ratios can be equivalent. And this should be a little bit of a review for you since we've already talked about this in class, but we are going to learn two new methods of how to see if ratios are equivalent. So everyone should have picked up these notes today in class, and we're going to go through these together. Over on the left-hand side, you're going to see the three different methods that we're going to use to find equivalent ratios. We have already learned how to find an equivalent ratio using tables, but we will review that at the end. But today, let's start up here at the top where it says, find the ratio of gray squares to total squares. So we have to make sure that we know it's asking for gray squares to total. So this is going to be a part to whole ratio. I can look at this and notice that I see 1, 2 gray squares. Therefore, the first part of my ratio is going to be a 2, followed by, I know that I see 1, 2, 3, 4, 5, 6, 7, 8, 9 total squares. Therefore, my ratio for part to whole, talking about gray squares to total squares, will have a ratio of 2 to 9. Now let's read the question down below that makes us think. If this pattern were doubled, what would happen to the ratio? Well, if it's doubled, I know that means that I'm taking it and I'm multiplying it by 2. So if I was looking at the ratio of 2 to 9 and I multiplied each section of my ratio by 2, I would get a ratio of 4 to 18. Well, that ratio of 4 to 18 can then be simplified since 4 and 18 share a common factor of 2 as they are both even numbers, thus making the ratio return to the ratio of 2/9. So to answer my question, if the pattern were doubled, what would happen to the ratio? It would remain the same. So now let's look at the two other examples. We're really going to look at 3, but let's start by looking at tape diagrams. So looking at tape diagrams in my problem here, it says Audrey and Megan were decorating for a birthday party. Audrey hangs 4 streamers in the same amount of time that Megan hangs 6. If Audrey hangs 12 streamers, how many will Megan hang? Well, I can use a tape diagram. In my tape diagram, I want to start by modeling the 4 streamers that Audrey hangs compared to the 6 streamers that Megan hangs in the same time. Now, if I'm increasing from 4 to 12, I am increasing by a factor of 3. Therefore, I can look at my tape diagram here, knowing that they covered that same amount of time. One hung 6 streamers. I would then multiply that by the same factor as well, thus making the amount of streamers that Megan hangs 18 streamers. The tape diagram just visualizes the first ratio comparing Audrey and the second part of the ratio comparing Megan. Then you still have to increase the tape diagrams by the exact same factor. Moving on, let's look at double number lines. Now in double number lines, we're just going to be counting using different amounts on each number line. So in the example it says, in the computer lab there is 1 PC, for every 3 Mac computers. If the computer lab has a total of 24 computers, how many are Macs? So, using a double number line where each number line starts off at 0, I'm going to continue this number line going by ones, since that's 1 PC, for every 3, 6, continuing on, Macs. Now it asks me if there is a total of 24 computers, how many are Macs? Well, I notice that the difference in my number lines between each set of the factors is it's increasing by 3. So I'm multiplying my number of PCs times 3 in order to get to my amount of Macs. So if I know that I have a total of 24 computers, I'm going to take that number 24 and I'm going to continue my number lines. So if I know when I have 1 PC and 3 Macs, that makes for a total of 4 computers. When I have 2 PCs, that means I have 6 Macs. I know I have a total of 8 computers. So I need to keep going up my number line. So I'm going to skip ahead to when I have 5 PCs. And I'm going to multiply that number because for every one of those PCs, I have 3 Macs. Therefore, 5 times 3 equals 15. So when I have 5 PCs and 15 Macs, it's a total of 20 computers. So I'm going to keep going on my double number line. When I have 6 PCs times 3, because I've got 3 Macs for each one of those PCs, I get 18. And I know that 18 plus 6 equals 24. Therefore, if I have 24 total computers, I'm going to have 18 Macs. So in this one, you're kind of using a little bit more of that guess and check. Now, I do want to take a second to just review our table method. In my opinion, the table method is going to be the easiest method. It's pretty similar to our double number line, though. So it says the ratio of men to women at the car wash is 4:7. What is another combination of men to women that the car wash can have? So I can use a table. I can have one side represent men, the other side represent women. I could start off with my beginning factor of the ratio 4:7, and I could increase them by a common factor. Perhaps I start by multiplying both by 2. I'm doubling the number of people there. So I would have 8 men for 14 women. I could even take our original number and I could multiply it by 3 instead. That would make 12 men to 21 women. I could even then take that and just multiply the 12 and 21 by 2 as I continue down, making equivalent ratios. So again, my ratio table is my favorite. They're all very similar in the sense that they all show us multiplying by a common factor. That's the only way to make equivalent ratios. They have to be proportionate in order to be equivalent. I hope this really helped you. And now what I want you to do is log on to Google Classroom, which you should already be in, and I want you to complete the 5-question homework assignment. At the end of the 5-question homework assignment, I want you to take note of your score.